In section 11.5, we're going to talk about area of a circle, but before we do, let's do a quick warm-up over 11.4. So push pause and answer these two questions. First, we're going to find the circumference of a circle with a radius of 12, and we want to leave answer in terms of pi. So circumference is equal to 2 pi r. And so that means circumference is going to be equal to 2 times pi times 12. And we want to leave in terms of pi, so we just multiply the 12 and the 2 to get circumference is equal to 24 pi. And then in number 2, we want to find the length of arc AB. And the length of arc AB is if I were to walk from A to B along the edge of the circle. And we know that the central angle here is 90 degrees, and then the radius is 3 meters. So we can find this by using the measure of that angle over 360 times 2 pi r. So we're going to find the circumference and multiply it by the percentage of circle that we have. So we have 90 of 360 degrees times 2 pi, and the radius is 3. And we want to leave this as an exact answer. So we can simplify this. We have 90 times 2 times 3, or 90 times 6, which is 540 pi over 360. And this does reduce to 3 pi over 2. Or just 3/2. And you can reduce that fraction by ignoring the pi and just reducing 540 over 360. And 180 goes into both of them, is how that reduces to 3 pi over 2. Let's take a look at 11.5, which has to do with area of a circle. And make sure you have this formula down, and then also go ahead and try to use try to answer the questions here before watching them on the video. Try to answer them on your own. So the area of a circle is A is equal to pi r squared. I think you probably have seen this before, but just keep in mind that if I have a circle, the area is how much paint it would take to paint the circle. That's the area. Or if it's if you think of it as a yard, the area is the amount of grass, and then the circumference in our case would be the amount of fence if the circle were a round fence. So we're looking for the area of a circle with radius 4, and we want to leave answer in terms of pi in this one. So that is an exact answer. So I have my formula, area is equal to pi r squared, and I know that radius is 4. And so when I square 4, I get 16, and I just leave it as 16 pi, as that is exact. And then on number 2, it says find the area of a circle with a diameter of 12. So be careful, because if diameter is 12, then I divide that by 2 to get the radius. That means the radius is 6. And so then I can find the area, which is pi r squared, which is pi times 6 squared. And be careful that you square 6 and don't multiply it times 2, which is a pretty common mistake. And so that means that the area is 36 pi. Now we want an approximate answer, and we're going to use 3.14 for pi. If you use your pi key on your calculator, that's okay as well. But if you use 3.14, you get 113.04. If you use your pi key on your calculator, that's actually a more accurate answer, and it's probably a little better answer, if it's even different at all when you round to those, to 2 decimals. And then yesterday we found, or in the previous section, we found the circumference of a circle, and then we found the arc length. Now we're going to find, we found the area, and then next we're going to find the area of a sector or a piece of the pie. So the sector is just part of a circle. And we'll just define it as a piece of pie from the circle. So the formula is you find the area of the whole circle. Notice that's just pi r squared. So that's the area of the whole circle. And then you multiply it times the percentage of the circle you have, which is the angle measure divided by 360. So once again, this is percentage of circle that you have, where m is the measure in degrees of the arc and r is the radius. So try to use that formula to find the area of these sectors. And so we're going to use area of SEC to represent the area of the sector. And that's the measure of the angle over 360 times pi r squared. So in this case, I have 70 over 360 times pi times 8 squared. And then we want to round our answers to the nearest hundredth, so we can just type this in our calculator. And we get 64 times pi times 70, and then divided by 360. And you get 39.10 when you round to the nearest hundredth. And we don't have any units, so we'll say units squared. Now on number 4, same thing, just different numbers. So we find our area of the sector to be equal to 85 degrees over 360 times pi r squared. And once again, make sure that you are squaring the radius and not taking it times 2. So that becomes 16 times pi times 85, and then divide it by 360. And you get an area of 11.87. And we don't have any units, so we'll just say square units or units squared. Okay, then the last problem we'll look at is this one, where we want to find the area of the shaded region. So the idea here is there are really 3 shapes involved. First, there's this rectangle, and then there's the left circle, and then there's the right circle. And our shaded region is the rectangle, but subtracted out the 2 circles. So let's find some, so our goal, I guess, before we get into that, is if we find the area of the rectangle and then just subtract the area of the 2 circles, we'll be good. So let's see what we know from this picture. We know if this is 6, then this is also 6. And then if that one's 12, this one is also 12. So I can assume, or if I know one radius to the circle, I know every radius. So this radius here would also be 6, and this radius here would also be 6, which makes this side 12, and this whole side is 12 plus 12, which is 24, as you count across. And so the area of this rectangle is just 12 times 24. So that's 288. We can write this over here. Area is area of the rectangle is base times height. 24 times 12, which is 288. And then my area of each circle with the radius of 6, and they're the same, we'll just do it once, is pi r squared, or pi times 6 squared. So that's 36 pi, and we'll just leave it as 36 pi for right now, because that's a little more exact. We'll round out the n. And so the area of the shaded region is equal to the area of the rectangle, 288, minus the area of one circle minus the area of another circle. And then now we can type this into our calculator to get 61.81 units squared. And these problems with the area of a shaded region will become important, so make sure you spend a little extra time with them when you're working on the assignment. Good luck with area of a circle, and thanks for watching this video.